and good evening. I'm Jennifer, and I am the former and current archivist for White Hat, and I'm going to be talking about several computer security issues that revolve around airplanes, some in the plane, some outside, and it's kind of a grab bag of different issues, so I'll start with the general plane computer basics and move on from there. First off, why airplanes? That tends to be an entire separate field of engineering entirely that doesn't seem to have much overlap at the outset. But however, computers today are a huge part of how and why planes work, and planes would be completely different without them. So I'm not an aerospace major, so I'm not going to focus too much on this part, but you need this general idea in order to grasp the rest of it. So planes today are currently what is known as fly-by-wire. This means that there is a computer system between what the pilot interacts with and the actual hydraulics and mechanics of the plane. So if the pilot pulls up on the yoke, that's going to interface with the computer, which then tells the plane which direction it needs to move in. In the past, the pilot's controls would directly link up with the hydraulics, but that is completely different from today. And that gives us the basic idea of there is always a computer between what the pilot does and what the plane is doing. So this computer has an integral part in getting the plane where it needs to be. So where does that leave us? It leaves us with this giant chain of what parts of the plane systems control what part of the plane and how severe it would be if part of it was compromised, with the red part being most severe and the purple part being the least. Theoretically, I'll get to that later. So we have several digital systems, each controlling a different part of the plane. The purple part is for maintaining the cabin, and everything in there is what the passengers have access to. And so if anyone wants to attack a plane, they have to go through that area. And there's also the aircraft control domain is the most important part because that is what the controls, or the avionics system for the aircraft is based in. And so these systems should all be separate, right? You don't want your person watching Game of Thrones in the back of the plane to be able to make the plane move, right? Well, ideally there should be a physical brake, but we don't know if that is always the case. Airplane manufacturers are very much not clear on the vast majority of software that is on their planes, and that definitely fits the case. Fortunately, the FAA has given us some hints as to what has been going on recently. In 2008, the FAA released a memo about the 787 when it was coming out. They were worried because they claimed that systems that controlled the avionics system were directly connected to the system that controls passenger entertainment. So a quote from them in their giant report was, "The proposed architecture is different. It allows new kinds of passenger connectivity to previously isolated data networks connected to systems that perform functions required for the safe operation of the plane." So that's not a good thing necessarily. And additionally, the FAA told Boeing they needed to prove that even though these systems are connected, they are somehow secure. They somehow did that. We don't know how they showed that these systems are secure. And another interesting point is people can comment on these memos. And Airbus left a comment claiming that the FAA's goal of you should have the systems entirely physically separated isn't a good one these current days, because a lot of data does have to pass from the plane controls to the in-flight entertainment system. So like if you've been on one of those overseas ocean flights where you can, on the screen in front of you, look at where the plane's traveling, the temperature outside and the airspeed, it gets all that from the avionics system. And in order to do that, there has to be some sort of controls or connections between. So now we have a few questions about these connected networks. How hard is it to gain access to unauthorized parts of this network? And the easiest way to do that, of course, would be the in-flight entertainment system, since that is what passengers have access to. Also, what is separating this passenger network from the aircraft control one? Ideally, there should be some sort of security barrier in between them, but however, we don't know exactly how that barrier works. So we're just left with this vague idea of they're connected somehow. on top of all of this, airplanes have a very unique security challenge in terms of costs. One estimate I found put the cost of changing one line of code in an avionics system at around $1 million, which makes sense if you consider it through the lens of, say, the Boeing 737 MAX crisis thing that's going on. They had to ground all the planes because of an issue in the MCAS, or maneuvering characteristics augmentation system. This system is in charge of, if it thinks the plane is at risk of stalling, pushing the nose down. Originally, it took data from one sensor and made that calculation, but now in the new software, they have to take data from two sensors, compare it, not do anything if the difference in angle of attack is very severe, and then whatever change it makes cannot be more than what a pilot controlling the plane can recover from in case it's incorrect. And so those are the general software changes they've said that they're having to make. These changes have been made and they've been testing, and these planes have still been grounded for months. After they go through testing, they're going to have to recertify all of this stuff. It's already caused a huge fiasco because it was incorrect in the first place. And that's for a non-security issue. And like, if they found a severe security threat on a plane and they had to do this, it would cost any airplane manufacturer a huge amount of money to do this. So any questions before moving on? Just the basics.
So is each piece of code specific to the airplane manufacturer itself?
There's a lot of different things. The in-flight entertainment systems are made by one of a couple of companies. Panasonic Aviation is one of them. Dell's Group's another. Those tend to share similar designs. The actual different parts are made by different people, but the hard part is a lot of that is not really like shared information, and so they can claim that there's some sort of security feature keeping data from moving one way to the other, but like it's a whole lot of one group claims one thing, another one says no, that's not how it works, and everyone goes no, yes it does, that is how it works. Anything else? Cool. Quick disclaimer before moving on. For some actual security issues, thanks for the meme, don't try this, please. Don't go out there and use a GPS jammer. Don't go out there on your next flight and be like, I'm going to hack the in-flight entertainment system. Don't be like, I'm going to throttle the engines. Just don't. It's illegal. It'll cause problems. The FBI will go after you. Taking a different bit of a turn, I'm going to talk about a vulnerability that definitely isn't unique to planes. It involves GPS interference, specifically GNSS, which is the Global Navigation Satellite System. This is the system planes use to tell their location, for the air traffic control to be able to know the location of the planes. And it's pretty important, especially, as we'll see later, for things like the plane landing, because they need to know exactly where they're landing. However, this system is easily susceptible to any sort of interference, whether it be from radio towers or people specifically trying to jam the signal. This brings GPS jammers into the field. As the name suggests, they're jammers that within some undefined radius jam GPS signals. So within that radius, you would not be able to make a phone call, track your location, any of that sort of thing. They're often sold as like personal privacy devices, but they're very much illegal or using them is very much illegal because for reasons of like if the person next to you needs to call 911, but you're jamming GPS signals, they would not be able to do that. And so they're illegal, but you can buy them online, which is why there's still a problem. So airplanes are susceptible to this jamming. There have been multiple instances of planes trying to land at an airport, but as they're getting closer to ground, suddenly they do not have the accurate location data, and so they have things like missed approaches where they miss the airport, so they have to turn back around there, try to land again. And it's a hassle in general for people flying the planes and for air traffic control because they're given very misleading data on where the plane actually is. So here's an image for a slightly related thing. This is a plane on approach to Manila Airport. That is not its actual path. There was a radio tower nearby that was causing a huge amount of interference at this airport. So the plane did not land at the airport in that path, but that is what the plane thought it was moving. So the actual path was very different, but when they're given this data, this is what causes missed approaches, is because they don't know where they are correctly. And GPS jammers, well, this is from a radio tower, can do similar things, especially around airports. How to prevent these? Fines. Lots and lots of expensive fines. So the FCC will go after people caught using these, especially around airports, and fine them a huge amount of money for using them. Some noticeable instances, one was around a Philadelphia airport. There was a truck driver, because truck drivers or people who drive company vehicles often buy these things because the company will put a tracker in the vehicle. So there's a truck driver sitting in a parking lot by the airport doing I don't know what, and the airport starts receiving reports of planes can't tell where exactly where they are, air traffic control can't tell exactly where the planes are, something's going on. So the FCC sends out a couple of agents, they find this guy, they take the jammer, they smash it and say, don't do that. He got off easy. There's another guy, same thing, sitting in a truck outside of the Newark airport, using a GPS jammer, doing whatever. Same problem, Newark airport's going, wait, there's someone jamming the GPS signals. They find this guy, take the jammer, say don't do that, smash it and fine him $32,000. So these things can be bought online for about $30, and yeah, that's their main approach to keeping people from using them, because it's not a problem unique to the airline industry. And so their main approach is to just put a huge amount of money on using them. So now,
So if you're allowed to buy them online, does that mean they're legal elsewhere?
I don't know exactly that. It is actually legal to own them. You can go online and buy one, but as long as you never plug it in, nothing you're doing is illegal. It's illegal to sell them in the US, it's illegal to use them, but buying them hasn't been a problem. It's like an article I read was talking about a journalist went and bought one. She never used it, so she was never in any sort of illegal area, but it's illegal to buy and use them.
So do those have like an insane range for actually jamming? If like a truck driver could be jamming for like an entire airport and like the planes around it?
I couldn't find anything on specific radiuses, which is part of the problem is people who buy them and use them, and a lot of people who are trying to catch people who use them, don't know the exact radius these things are jamming. It can vary for a single device too. And so one person who thinks they're just blocking off their own location is actually causing problems for a plane over at the airport across the street. Okay, so a security issue that is actually within the plane. I'm going to touch on Inflight Entertainment Systems, or IFVs is the shorthand for that. And they include the seat back units, but there's a couple other pieces too that you probably wouldn't think of at first. Oh, these are in a very unique position because they are a part of the plane's network that is physically accessible and usable by passengers. They're manufactured by several different companies and are often running Linux. I read the most recent ones are running some sort of Android. And where a lot of this information comes is a security researcher just Googled them and found some firmware updates for the Panasonic Avionics model, posted online, and decompiled those and read through what they did. So here's a model of the different parts of an IFV system. You have the part you normally think of, the seat display unit, or the SDU, and occasionally if you've been on one of the longer flights, the personal control unit, so the sort of remote that comes with it. The cabin crew panel is used by flight attendants for things such as the PA system, lighting, climate control, all the stuff that wouldn't crash a plane, but you need for people to be comfortable. And the system control unit is the actual, near the connection from the airplane controls to the IFV system. So the system control unit gets information from the avionics system, like altitude, speed, location, and passes that all through a certain avionics bus to the rest of the system. And so that's a key point in the link of all these things. So, first off, the firmware update revealed some fun things for IFVs. And this piece of code, which was found in a publicly hosted firmware update, it's a piece of PHP used for a between-seat chat feature. And you got a nice, from the talk a few weeks ago, we got a nice SQL problem here. this person was actually able to, while in flight with the control unit provided, drop a full list of movies from the table. And so he was also able to bypass the credit card check, because these things are not normally done in real time on a plane. So he bypassed the credit card check, was able to access random files, and dropped a whole list of movies. He was doing it as part of a bug bounty program. But it's just a whole list of things that you should not be able to do in the system that is connected to a plane. And this is someone who was not trying to take advantage of the system for more than just research. Like, imagine if someone truly wanted to get into the system and cause problems for the plane. So some things they might be able to do if you gain access to the IFV system is that cabin control thing I talked about. If they could mess with the lights, climate control, they'd also might be able to spoof any sort of data about where the plane is. The plane wouldn't be over the Pacific Ocean, but you could make it appear to passengers looking at the location screen that the plane is over the Pacific Ocean. And so nothing directly in the IFV could cause the plane to crash, but you could definitely cause people inside the plane to become very worried. So how far can you take this? So in 2015, a security researcher was removed from a flight. It was either his previous flight or this one, his second flight. He claimed on Twitter, great idea, oh yeah, and I hacked the plane, was able to throttle the engines. So the FBI pulled him off his flight, and then you get into this whole confusing mess, because this person is under no obligation to tell the FBI what he did, and if he runs a huge risk of going to jail. So I read multiple different things about him claiming completely contradictory things, the FBI claiming completely contradictory things, because they weren't exactly sure what happened. I think ultimately what he decided on was that, or what he said was that because he had gained access to the IFV before, he had made a virtual model of the plane's network, and then he hacked this virtual model, and throttled an engine in the virtual model, not an actual plane. But it's still a confusing question of what did he actually do. And additionally, he claimed he had plugged his laptop into the IFV in front of him, which brings up an interesting physical security problem. So this physical security problem is the seat electronic box. It is found underneath each of the seats. So I tried to look for it once. I wasn't able to find it. Apparently they're pretty well hidden. But they're not locked. They have ports on them. And so this guy had a modified port. They could plug it into an SEB, pulled the cover off, and stuck it in. And he claims he didn't do that. The FBI said he did. He also brought up a point of, the FBI said, well, the box was damaged. Like, those things are under seats. They put them there by where people shove their luggage. They're bound to be damaged at some point. And they're not really protected, just under this hope of maybe it's under the seat and it's disgusting and no one cleans there. Hopefully no one's looking for a plug. But so that's a huge issue, because even if you were able to perfectly remove all the vulnerabilities within the IFV, do you want to give someone access to the ports? So is there any way for us to tell if he hacked this plane? There may be part of one, and that Avionics Data Bus I was talking about that interfaces with the SCU and takes data from the avionics system. I read a lot of those are the ARINC 429 Avionics Data Bus, which a whole lot of confusing letters, but those only transmit data one way. And what I heard is, well, if it was on a plane with this specific data bus, then they can only send data from the avionics system to the IFV and not the reverse. So therefore, he can do whatever he wanted in the IFV, but nothing can move the other way. It's physically impossible. However, in some more recent planes, including the Boeing 777, those things are ARINC 629 buses, which are two-way. So we can't say. I don't know exactly what plane he was on. If he was on one with a 629, we might not exactly be able to know. And so that leads into a huge problem of what kind of data bus was there. And if it was the 629, what preventions are there in the avionics system to keep it from accepting data from the IFV? Does the system have any way of knowing, oh, someone in the back of the cabin told me to throttle the engines? it's not from this certain trusted area, I should ignore it? Or does the system just take anything? And that's another piece of knowledge that we don't have the ability to know, because like those systems are not open to anyone to just look at. So, is there any way to test this? United, I found, actually has a bug bounty program that, for very reasonable and understandable reasons, bans bugs in onboard Wi-Fi and entertainment systems and avionics, and bans testing on any aircraft or aircraft systems. So I understand why they do that, but that leads us back to the point of, how do people go about testing these systems? Sure, there was a bug bounty on one of the IFVs, but you can't just go out. If you're part of a security team who says, I want to hack something, do you have multi-million dollars to go out and buy your own commercial aircraft? Do you have a pilot trained to fly commercial aircraft? Do you have jet fuel? Do you have a place to store and maintain this plane? What do you have access to? And that's a huge amount of money and time and personnel that people in security probably don't even have the ability to go out and buy a plane as easily as, say, an airline or one other entity, which is the Department of Homeland Security. Last year, they hacked a Boeing 757. They got the plane, parked it outside an airport for a couple days, and from what they said they only used things that you can bring through airport security, and they never entered the plane, which brings up two huge problems. One of them was this barrier to airplane hacking was always no one would hack it because they'd have to be on it, and no one wants to crash the plane they're on. But if you can access the avionics system from outside the plane, that's a whole huge problem. And same with people assume, because they can't exactly release what they did, this has not been fixed, that they use some sort of radio communications in order to hack it, because you can bring certain radio equipment through security, and radio stuff is used in the controls. But you can't tell exactly what they did because they can't release it. And so they also, their goal of this, according to the person in DHS who ran this whole team, was to raise awareness for security flaws within planes, because they found, talking to hackers, that hackers were very aware that there would be security vulnerabilities inside a plane's computer system. Pilots were very disturbed to hear that that was a possibility. So they ran this whole program to show, yes, it is possible. It's not just this myth that someone can hack a plane. It can be done. There was one problem, though, is that they released everything that they did to Boeing, and Boeing said Boeing said that that the test did not identify any computer security vulnerabilities on the 757. So there's a direct contradiction between what a government agency is claiming they did and what a airplane manufacturer claims they did. And so in that case, it's, who do you believe, the DHS or Boeing? So the results of this are, overall, airplane manufacturers have been underestimating the extent of these vulnerabilities for years. They cost a lot of money and take a lot of time to fix, so they don't really want to go hunt them out themselves, and they face little pressure to fix them because most people, unless you're a government agency with cash to burn, can go out and buy their own plane and hack it and say, hey, look, there's a problem here. It's not like a self-driving car or a phone where a team or even an individual can go out, buy the thing, and try to figure out where the vulnerabilities are. It's a giant plane, so they don't face that pressure. Additionally, as far as we know, there hasn't been an actual emergency or crash caused by someone hacking a plane, and so they don't face pressure on that front either. And so there's just this huge vacuum of none of this knowledge is going to come into the industry because no one can really provide it. And the people making the planes aren't really going to go out there and find it either. So some other noteworthy issues, or any questions on the previous ones? Cool. Some other noteworthy issues. I didn't have enough information to spread these out as far, but while they may not be hacking an airplane or causing problems to an airplane, they definitely relate into the whole system of air travel. One is cameras and seatbacks and that whole privacy issue. Did y'all hear about that? someone tweeted a couple months back while they were on a flight that, hey, it looks like there's this camera underneath the seatback display unit in front of me. What's going on here? And a whole bunch of people looked at them and said, yeah, wait, there's a camera there. Turns out some of the newer models for these displays included a camera for what the airlines claimed was a possible future video chat feature. And they currently weren't in use. And that freaked a lot of people out, understandably, because you have this unused camera pointing at you for the duration of your flight that they claim it's unused. Who knows? Given what we talked about with previous vulnerabilities in the system, that doesn't mean that even if the airline isn't using it, that doesn't mean that someone who wants to use it with enough knowledge can go in there and gain access to it. And so a lot of people were worried with those cameras just suddenly appearing without any use and an explanation, and no one had pointed it out. None of the airlines had pointed it out. None of the manufacturers had, until someone went online and said, hey, this looks weird. United recently actually announced that they're going to cover them up, just put something over them, because enough people have said, hey, we're not comfortable with this unused camera staring at us the entire flight. This is creepy. It's an invasion of my privacy. So I think they're going to put something over it, and I don't know if other airlines will follow suit, but there's definitely been some outrage over that, understandably. Another issue relates more to airlines in general. You can have the most secure plane ever, but if you practice no security practices within your airline, who knows, like you can have credit card numbers being stolen, you can have access to things people should not have access to. And that's what happened in this case. There was an airplane crash in Spain a few years ago, and what happened was this plane crashed for some other technical or person-caused reasons. It was not caused by a computer issue, but this plane crashed. And what happens is the Spanish government has to examine the airline as a whole and say, where did things go wrong? What are some problems here? And while they were examining this airline's maintenance facility, they found malware on one of the computers, which this malware wasn't airline specific. It just was malware that happened to make it to that computer. But that raises this huge concern of, if that malware could make it to that airline's computer, what if someone wanted to put some form of malware that did, say, delete maintenance records on someone's computer? It's clear they're missing some form of security practices here if malware could make it on the computer in the first place. And while the malware didn't cause the crash of the plane, it raised this whole issue of these computers that the airline is using for maintenance aren't secure, and these maintenance records need to be kept well, because if people start deleting them, then small issues could become huge ones that could cause huge problems. Or if someone starts messing with them, things won't get fixed correctly. And or even if that they have the same issue with things like where they store credit cards or personal information or pilot information. While I've been focusing mainly on what affects an aircraft in the terms of air travel, these things, or airlines in general, are also affected by all the same things. Then any other questions?